You got to look at what's given. Was the amount given or the rate given? In this problem. It was the rates. Now, in one of the previous problems we just did, I gave you a function that represented the rate in and another function that represented the rate out. This one does not give you the rate in and the rate out. It just gives you overall rate. So, in the previous example, the rate in and the rate out both had to be positive value. Both had to be positive functions. In this case, could this be a positive, just strictly positive? If the rate is strictly positive, what does that mean about mosquitoes? The number of mosquitoes is always increasing, right? So that would be maybe a bad thing, yeah?
That's actually bad, yeah.
Okay, thank you for your insight. Okay. All right. So R is the overall rate, and it says there are 1,000 mosquitoes at T equals 0. So what is that again? Initial condition, okay? All right, part A, show that the number of mosquitoes is increasing at T equals 6. How do you know if the amount of mosquitoes... If the what? If the rate is positive. We would like to say the derivative. But if we take the derivative of this function, what are we finding? Kind of the acceleration. That's weird. So it's just when the rate is positive. I gave you the rate, so we're just going to find R of 6. What's R of 6? 4.438? Is that an agreement? Okay. Therefore, what can we say? Since R of 6 is what? Greater than 0, the amount of mosquitoes, how do you spell mosquitoes, is what? Is increasing. Okay, that's that on that one. Are we good with that? Yes? No? Yeah?
Like, let's say you have a position, right?
Right? Oh, like the antiderivative of position?
Yes.
It does.
Is that a B? Is that because this B?
Well, I'll give you one example real fast. What is the antiderivative of position, or the antiderivative of an amount? I don't know. But here's what I do know. If I say the integral of an amount, let's say x of t for position, right? From 0 to, well, we'll do this. Let's say mosquitoes. So m represents the number of mosquitoes, right? If I take the antiderivative of that, I don't know what that means. But if I do this, 1 over t minus 0, what is this? It's the average what? Value of the number of mosquitoes. So there is a point where you will take the integral of an amount, but then you'll divide it by a time interval, and it gives you the average amount. Okay. All right. In fact, that might be the case here. I don't know. Part B. At t equals 6, is the number of mosquitoes increasing at an increasing rate, or mosquitoes increasing at a decreasing rate? We already know at t equals 6, the amount of mosquitoes is increasing. How do you know if it's increasing at an increasing rate or a decreasing rate? So we've got to find r prime of 6. Do you have to find the derivative yourself? No, it's a calculated problem, so just take the derivative, evaluate it when t equals 6. What do we get? Negative 1.913? Do I have an agreement on that? So, in other words, if you look at the graph of the number of mosquitoes, we know that that graph is increasing because the number of mosquitoes is increasing because R, the rate, is positive. But it's slowing down. The rate is slowing down because R prime is negative. It says at t equals 6, is the number of mosquitoes increasing at an increasing rate or increasing at a decreasing rate? We already know it's increasing because R is positive, because the rate is positive. If I want to know if it's increasing at an increasing rate, I have to take the acceleration, which isn't really, but R prime. So we would say increasing at a decreasing rate since R of 6 is greater than 0 and r prime of 6 is less than 0. Okay. I took the derivative of the rate to figure out if the rate is increasing or decreasing. All right. According to the model, how many mosquitoes will be on the island at t equals 31? How do you figure out the amount of mosquitoes on the island at a given time? If I just take the integral, I'm finding the change in the amount. What do I have to include to? Right. So at t equals 1,000, or at t equals 0, there was 1,000. So 1,000 mosquitoes plus the integral from 0 to 31 of r of t dt. Why? Because r is a rate. The integral of a rate is an amount. So what do you get here? What'd you get? 964.335? Yes. So somewhere along the way, some native grabbed a mosquito and ate 2/3 of it? I don't know. So we would say 964 mosquitoes. Part D. To the nearest whole number, what is the maximum number of mosquitoes? So we're looking for the maximum of R. No. We're looking for the maximum number of mosquitoes. So what do I have to consider? No. R is the rate. So the number of mosquitoes, to find the maximum number of mosquitoes, I have to take the derivative of the number, which is R, right? So the critical points are when R of t does what? Equals 0. Okay? So that is when t equals, when does R of t equal 0? Since R is the rate. 7.854? 23.562? You have R in your graph, in your Y list, right? Finding the zeros. Okay, graph it, find the zeros. Is that right? 2.5 pi, that seems reasonable. And 7.5 pi, yeah, that seems reasonable. Okay. And what do we have to consider to find, what are all our critical points? T equals 0, 7.854, 23.562, and 31. So it's just like the other problem. You've got to maybe create a table. So T versus number of mosquitoes. We already know how many mosquitoes at T equals 0. 1,000. We don't know at 7.854. We don't know at 23.562. But we've already figured out at 31. What was that? 964. So, again, how am I going to find the amount at 7.854? But include your initial condition, too. So 1,000 plus the integral from 0 to 7.854 of r of t dt. And then for 23, that'll be 1,000 plus the integral from 0 to 23.562 of r of t dt. So what are these values? What's the integral from 0 to 7 plus 1,000? Say that again. 1,000 what? 357. And then from, or at t equals 23.562? Okay. And what does it say? To the nearest whole number, what is the maximum number? So in this case, it's not asking for when, it's asking for what. So what is the maximum number? 1,039 mosquitoes. Okay, so part 1, you get 1 point for saying r of 6 is greater than 0. Part B, you have to consider r prime of 6, and so you get a point for that and a point for your answer saying it's at a increasing at a decreasing rate because r prime is negative. Part C, you get 2 points, one for the integral here, and then one for the answer, so you included the initial condition. Part D, 2 points for the absolute maximum value. So 1 point for the integral, 1 point for the answer, and then 2 points for the analysis. So basically setting r of t equal to 0, and then all of this. All right. This is number 17, I believe, right? Let's go over this, okay? And as you go along this, if you were legitimate when you were doing it, you tried it, you didn't go look up the answers and everything else, keep track of your score and see how you compare, okay? So number 17, the traffic flow, and this is, for whatever reason, this sentence tends to cause a little confusion on this particular problem. The traffic flow is defined as a rate. That's important. Traffic flow is a rate measured in cars per minute. The traffic flow at a particular intersection is modeled by F. So, I give you F. Is F a rate, an acceleration, I guess you could say, or is it a position type of function? It's a rate. It says traffic flow is a rate, and the units are cars per minute. F is traffic flow, so F is a rate. Yeah, in this case, they just defined it this way. Okay, so capital F in this case is the traffic flow rate. A, to the nearest whole number, how many cars pass through the intersection over 30-minute period? How do you know how many cars pass through the intersection? Okay. If F is a rate, how do I figure out an amount? The integral. Now, we would say what? The integral of, or from 0 to 30? 30 minutes? Is this minutes? Yes. Of f of t dt. You guys okay with this? What do you get? 24. I need this. I'm sure it's a decimal, so help me. I know, but decimals. I understand that, but you won't say the integral is equal to this. 0.078? Okay. Honestly, this is what they expect. Okay. Now, that's not your answer. Your final answer is round to the nearest car. So you would say 2474 cars. So for those that are part of the Youth and Government Day, anybody in charge of traffic flow and figuring out lights and things like that? Anybody in that? Do they have that role? Right. But my point is, this is the kind of calculations, they collect data, how many people pass through, or the rate at which people pass through, and they do the calculus on it to figure out if the street light is necessary or not. And I think that's this problem anyways. So there's, in that 30-minute period, 2,500 cars pass through that light. Is the traffic flow increasing or decreasing at t equals 7? Is the traffic flow increasing or decreasing? This is why this problem is a little confusing. The traffic flow is represented by what? F. How do I know if the traffic flow is increasing? If a function is increasing, that means its derivative is positive. Okay? Now, if I give you a rate and I ask if the amount is increasing, would you take the derivative of the rate? I know, that's why this makes it difficult. If I give you, for example, velocity, and I say, is, velocity equals something, is position, whatever, increasing, then would you take the derivative of velocity? No, because this is the derivative of this, right? But if I say, is velocity increasing, then you'd have to take the derivative of velocity. You guys follow me? Say, okay. So if I want to know if the traffic flow is increasing, that means I'm asking for, is F increasing? So I have to take F prime, right? At 7, so what's it going to say? F prime of 7, what is that? There's no 0. 873? Okay. So is the traffic flow increasing or decreasing? You would say decreasing. Decreasing since f prime of 7 is less than 0. Or f prime of 7 is negative. You guys okay with this? Yes? Yes. Okay. So that tells you the amount of cars that's going through at t equals 7 is not as great as other times before. All right. What is the average value of traffic flow. Okay, but what's the integrand going to be? The average value of traffic flow. So, what's traffic flow? F. Okay, so it'll be 1 over 15 minus 10, integral from 10 to 15 of f of t dt. All right, so what do we get for that? 8, 9, 9, 9. Okay, so what's the units on this? This is a good one. F of t is what? Cars per minute. We had this on a quiz. Cars per minute. When I take the integral, what do I get? Cars. And when I divide it by time, cars per minute. Besides that, this is the average traffic flow. What's the units on traffic flow? Cars per minute. So the average traffic flow is cars per minute. Okay? So on average, over this time interval from 10 to 15, on average, there's 82 cars-ish that pass through the intersection, okay, per minute. What is the average rate of change? Yeah. If I want the average rate of traffic flow, I would find f of, what is it? 15 minus 10? Minus f of 10? Over 15 minus 10. What do we get there? 518. Okay. Indicate units of measure. If I take the derivative, if I take the rate, yeah. Cars per minute squared. Okay. Was that it? Okay, let's take a look at the scale, the grading scale here. All right. Part A, you're going to get one. This is pretty easy, in my opinion. You get 1 point for having the correct limit. So as long as you set up an integral and you put the correct limits down, 0 to 30, you get 1 point. You get 1 point for the correct integrand. So if you put capital F of t, if you put like f prime, then it's wrong. Okay, and then you get 1 point for the correct answer here. Part B, you get 1 point for the answer with the reason. So it's decreasing because f prime is negative. Part C, you get 1 point for the limits, 1 point for the correct integrand, 1 point for the correct answer. And then part D, 1 point for the correct answer with units. You guys okay with this? Because we're looking for the average rate of F. F was cars per minute, so the rate of F is cars per minute squared.